Hello students, this is my second class on this hydraulic engineering subject. In the first class we discussed about the detailed syllabus, what we are going to study. We discussed about the learning objectives, what we learn after studying this subject, that we discussed. And also we discussed how you apply in the field. After studying this subject, how you will apply in the field, that we discussed. Okay. So this is the second class, and here we'll start our chapter 1, that is fluid properties. The properties of fluid we'll discuss in today's class. First of all, you should know what is fluid. Fluid is nothing but that is liquid or gas. Gas can be fluid or liquid, which can flow or which can deform under the application of tangential or shear forces. Under the application of tangential and shear forces. Solid, it can resist tensile stress, compressive stress, shear stress, all type of stress it can resist to some extent. Okay, to some extent means after that there will be deformation, and solid will not have capable to resist all these stress. So initially it will resist, but the fluid, it can resist the compressive stress only when it is in a closed boundary or closed container. A closed container, if you apply compressive stress, it will resist. Otherwise, it will not resist to any forces. Next is gas. Gas, it can be compressed. There is difference between liquid and gas. Although both are called fluid, but there is little difference in this here with respect to this compressive stress. Here it can resist if you close it in a container. But this can be compressed much readily even if you close it or if you open it or any mode. It can be compressed under the action of external forces. Next is mechanics. What is the mechanics? It is the applied mathematics. We know that is the application of applied mathematics. It deals with the effect of energy, forces on the body at rest or motion. If you apply energy and forces on the body at rest, when body is at rest or motion, the effect of the energy and forces on the body, that is called mechanics. What is fluid mechanics? So that mechanics deals with the fluid. It is the study of mainly the characteristics of the fluid under condition of rest or motion, under the application of forces or under the application of some external forces. Okay. Fluid statics. Statics means that is rest. That is also called hydrostatic. When fluid is at rest, that is called hydrostatic. The study of incompressible fluid, only liquid. Okay. Only liquid. Incompressible fluid means only liquid, because gas is not incompressible fluid. Gas can be compressed. That's why only liquid under static condition. That is called fluid static. Study of incompressible fluid, that is liquid, under the static condition or under the rest. When there is no external forces on this fluid acting on the fluid. So if you want to study the gas on static condition or at rest, that is called aerostatics. Next is fluid kinematics. It is study of velocity and acceleration during fluid motion without going through the forces causing the motion. We need to study the characteristic of the fluid when it is at motion without studying the forces which causing the motion. Means forces or the energies causing the motion are not dealt in this chapter, that is fluid kinematics. But in fluid dynamics, the forces which are causing the motion, the energy or forces which are causing the motion of the fluid, that is studied here. So this is the study of velocity and acceleration during fluid motion with the forces causing the motion. Next is the ideal fluid. Ideal fluid means neither it is viscosity, nor surface tension, nor this compressibility. That's incompressible. Or density remains constant. If it can compress, the density obviously will change. For same mass, volume will change, so the density will change. So if it is incompressible, means if you cannot compress it, then density will remain constant. That is called ideal fluid. Zero viscosity, zero surface tension, and incompressible, means density remains constant. That's called ideal fluid. In case of real fluid, if all these terms changes, means like viscosity changes, surface tension changes, and density changes, means it can be compressible. That's called real fluid. Whatever the fluid you were seeing in the real nature, that is called real fluid, not the ideal fluid. The density, we know, whatever the fluid is present in nature, that we are seeing in the nature, that is all are real fluid. There is no fluid which is ideal. Even if water, pure water, it has some viscosity, some surface tension, it is also so density also changes if you change the temperature. Real fluid, that is a real fluid. The density, you know that density is nothing but the mass per volume. The unit you know gram per cc, kg per meter cube, gram per cc in CGS, kg per meter cube in MKs. For water, it is 1 gram per cc, or you can write 1000 kg per meter cube. Weight density. Weight density means the weight per unit volume. Like here, mass per unit volume, it is weight per unit volume. That's mass into acceleration due to gravity, that is g. Mass into g divided by volume, which is equal to rho into g. The unit of weight density in CGS unit is dyne per cc. In MKS unit is Newton per meter cube. So for water, it is 9.81 kilonewton per meter cube, or you can write 9810 Newton per meter cube. Next is specific volume. Specific volume is the 1 by rho, or reciprocal of density, or the volume per unit mass. Volume per unit mass. That is 1 by rho. Specific gravity is the density with respect to density of water. That is the ratio of density with the density of water. Or you can write, if you multiply g here and g here, you can write the weight per weight of water. It is unitless. Okay, if here it is kg per meter cube, it is kg per meter cube, then it will be unitless. So for water, it is 1. Next is viscosity. What is this viscosity? Viscosity is the resistance of fluid against shear stress due to cohesion and molecular momentum exchange between fluid layers. Means, this is the plot. This is the plot between the velocity and thickness of the fluid. For change in thickness, there is change in velocity. So this change in velocity, per unit change, this is the plot. Okay, between the, if velocity we apply, the thickness, okay, it will changes. Then this is the change in velocity per unit change in thickness. That is called velocity gradient. Okay, means here in this case, this is actually, again, just I'm telling here, this is the boundary. Okay, this is the fluid layer. These are the fluid layers. Okay, above this boundary there is fluid. Along this along this thickness or depth of the water, the velocity increases. Here it is 0 velocity at the boundary. Gradually it increases. Okay, gradually it increases. And up to this fluid is layer is up to this. Okay, then here it will be maximum. At this point it will be maximum. Okay, so here it is 0, so there will be gradual increase of velocity. So if per small change in thickness, okay, there will be change in velocity. That change in velocity, this change, okay, that is du, this is dy. This du by dy is called velocity gradient. Okay, due to the cohesive force between the molecules of the water or the liquid and the momentum exchange, molecular momentum exchange between the layers, this fluid resists the shear stress. If you apply the shear stress, then it will resist. That, according to Newton's law, okay, this shear stress is directly proportional to velocity gradient du by dy, or the shear stress is equal to this viscosity into du by dy, and this resistance is due to this viscosity. This where mu is coefficient of coefficient of dynamic viscosity, that is called velocity gradient, and this coefficient of dynamic viscosity is can be formulated as tau divided by du by dy. So unit of this coefficient of dynamic viscosity in CGS, it is dyne second per cm square, or it is one poise. It is called poise. In MKS, it is Newton second per meter square, 1 pass. If you convert this to unit, 1 pass is equal to 10 poise. And for water, the coefficient of viscosity value is 1 centipoise, or 1 by 100 poise. Okay. Next is kinematic viscosity. Kinematic viscosity is the ratio of dynamic viscosity, coefficient of dynamic viscosity, with the density. The unit is meter square per second in SI or MKS. This is just, it is 1 centimeter square per second, or it is called 1 stroke. The fluid which obeys Newton's law is called Newtonian fluid. Means the fluid in which the shear stress directly proportional to velocity gradient, that is called Newtonian fluid. The fluid which does not obey, it is called non-Newtonian fluid. And in liquid, if viscosity decreases with the increase in temperature and vice versa. If you increase the temperature, the kinetic energy increases, the velocity gradient increases. So if you increase the gradient, velocity gradient, then the viscosity decreases, because viscosity is here inversely proportional to this velocity gradient. So in case of gas, it is different. Scenario is different. Viscosity increases with increase in temperature. Pressure has no effect on viscosity. Even if you increase or decrease the pressure, there is no effect on the viscosity. This is a plot between the shear stress and velocity gradient. For ideal fluid, there is no viscosity, so shear stress is 0. So this axis, this x-axis shows itself that is the ideal fluid. This is the elastic solid, this y-axis. Okay, elastic solid means even if you apply continuously, if you apply the shear stress, there is no deformation. That is called elastic solid. Newtonian fluid, that is here you can see, that is this one is tau is directly proportional to mu by mu or du by dy. A Newtonian fluid. Non-Newtonian fluid, this one and also this one. This can be this part, it can be this part. Means it's not directly proportional to, but if it increases, the shear stress increases with the velocity gradient, but it's not directly proportional to. Ideal plastic. Ideal plastic means this. Ideal plastic means that it is also it obeys the Newton's law, but after some after applying this shear stress, okay, after some extent, then it is obeys the Newton's law of viscosity. This is thixotropic substance. It is kind of this non-Newtonians increases the velocity gradient increases with the stress test, but after applying some shear stress, not from starting. Okay, after applying some shear stress, it increases. That is called thiotropic substance. This is about surface tension. Tension at surface film of the fluid due to unbalanced intermolecular attraction at the open boundary. This is a liquid. Okay, this is this molecule. Okay, inside here you have the molecule inside. Okay, one molecule at the surface. Here you see due to the cohesive forces between the molecules of the fluid,